So what I got so far is the signal itself is being drawn here, but that's not enough. So let me try to do some documentation on this guy. First, tomorrow I need to my team support me to read this code and try to understand all the function I'm using. That is very important thing to do actually. So this is the plot wave 5. The second thing is using FFT with audio in MATLAB. So I hope someone already do this for me, so I don't need to spend too much time doing the research on my own. It's a lot of waste of time actually, because someone already done it. Yeah, so you see they just get the data right away and put it in the function and they plot it, and that's all. I don't know why it's so easy like that, but I'm going to try to reuse this code another time. So this time is using FFT function, and we will take a look what is the FFT means later. So the first plot I'm using x1 and the second plot I'm using x2, and now we try to run it here, and I sterilize it. And obviously there's some error. I didn't know what is the data means, so what I'm going to do is I will replace it with the y1, and let me rerun this application another time. So I'll sterilize it. Yeah, so amazing. You see, it's now the noise is reduced down, and the feature is you know what, it has two how to say this, the first signal and the last signal is the pointing upward, which is the, I don't know why, I don't know what the magic behind this. That is a question actually we need to figure out. So let me try to plot the second female voice with the same method. So this is FFT 1 with the y1, and I'll try to use with FFT2 with the y2, and to drawing with use the same method. We try to open on it, and it should have a color for that. So let me try to visualize it again. Okay, that's fine. Some syntax error. So run it again. Routing to audio. Unlike it. Okay, so finally we see some difference now. There's a tiny bit of difference. I still don't get it. I still don't understand what is FFT and how it draws it on the graph. I still don't understand the meaning of this graph. So that is what I really need to figure out. So when we finally figure out, we can start. You know, when I present with the professor, I want to explain each of these graph means. You know, and then. And when I understand the code, what I'm doing, then I can really finish the course. So let's me move on actually. Let me move on. So the only ways to move on this is actually I need to return this DAOs FFT. So now I have option. I will keep moving on and try to use FFT to find frequency. Okay. So the question this guy made is, I want to know the frequency of the data. I had a little bit idea that it can be done using FFT, but I am not sure how to do it. Once I pass the entire data to FFT, then it is giving me two peak. But now, how can I get frequency? So I input the data. It gives him two peaks, and his question is how can he get the frequency? So he put in the data x and he got the x is the result, and x is peak at the n0 and big N minus n0, and sinusoid frequencies is f0, right? Fs multiplied with n0 divided to n, big N, right? So for example, if frequency is 8,000 sample per second, right? So 8,000 sample per second. Big N, so it's 2,000 sample is the 16,000. So and that means the frequent is happen in x seconds, right? So in 2 seconds, because we have 16,000 sample divided to the frequency of 800 sample per second, then we have 2 seconds, right? So if x equal to FFT, x pick as the 2,000 and 14,000, right? Therefore f0 is the 8,000 multiplied to 2,000 divided to 16,000 equal to 1,000 SC, right? So what is conclusion here? So 8,000 is actually the frequency is due to some sample per second. That's what we know now. The 60,000 is the total sample, is the length of the data, right? And and because he multiplied to 2,000, then we got the result. So what is conclusion actually? Can we get the conclusion of here? How can I with the FT in MATLAB? So I'm just trying to search this another time. I'm not using any AI here. I'm not going to do that. So there's a guy who had a paper research on the frequency difference between male and female voice, and when we get the specific frequency of the same age, right, it depends on the age as well, and depending on the country, the language itself also. So different country, different language, different age, result in different frequency to identify male and female. That is if we use FFT for that. So they do have a frequency here, for example, like a French person, right? Age from 20 and 61, the frequency should be 145, right? So this paper is actually very good to refer. Actually, I will try to adopt this paper as a guideline for my stuff, for my input. So I will try to download this paper right now to refer on it. In all the answer, they do have the general correction. So this guy come in the same problems as me having. He also record a wave, he use AFT on the wave. He gives statistic and count the frequency, and he define rule. So if lower frequency, then more the voice the male, and if more upper frequency, then the voice the female. Is that true? Is that true overall? Let me just run the program again to just visualize. So let me try it. Female here. Female is the first one, male is the second one, and standardized. Yeah, so definitely true. That is true actually. The male voice is actually having lower frequency. It's a lot deeper, right? And the female is a little bit higher in tone. So how can I figure out? Okay, so there's a sample code here which is really interesting, but this is the Python code actually. I will just try to read it. So the combine is actually he used Ravel. I'm not sure it's Ravel mean in AFT. So he also used FS, right? He used size. He used a combine. He used combine size. He used sum of the combine. He divide some combine to combine size, and he got the mid frequency. So interesting. Actually, I will record this as something I will try to remember. Okay, so now I need to understand the code. What is the Ravel means? So I will go back in the third module. So be right back. Talk to you later.